Okay, we ran out of time, so let's finish up this problem. And we were going to eliminate x, and we're going to have to multiply the bottom equation by 5 to make that happen. So let's just go over here. I'm not going to do anything to the top equation. But the bottom equation multiplied by 5 looks like this. Negative 5x plus 10z is negative 45. Okay, and addition will eliminate x. So 9 plus 10 is 19, z. And negative 12 plus negative 45 is negative 57. So we get our first variable, z is negative 3. To find the next variable, now that I've found one variable, I'm going to pick out an equation that has two variables. And it really doesn't matter which one you choose. Maybe this one. So I'm going to have negative x plus 2 times negative 3 equals negative 9. Well, that's obviously negative 6. So negative x equals negative 3. So positive x equals positive 3. Okay, 2 down, 1 to go. And now I'm going to go all the way back to the beginning where I've got 3 variables. So after you found the first two variables, then pick out an equation out of the original 3 and substitute in. So x is 3. We don't know y yet. Z is negative 3. And all that equals 4. Well, the positive 3 and the negative 3 would just cancel each other. 2y equals 4. So y is 2. So my final answer as an ordered triple, x is 3, y is 2, z is negative 3. Okay, moving right along. This is number 10. And we're supposed to graph this absolute value function. Well, remember, absolute value means it's going to produce a V shape. And we need to find the vertex, the point of the V. And here's how we do it. We solve for y first by adding 4 to both sides. So y is going to be the absolute value of 4x plus 8 minus 3. Our little formula for finding the vertex is the opposite of b over m and c. That makes up the vertex. So in my function, this number in front of x is m. The number being added to it is b. And the number that's always outside by itself is c. And if there is no number out there, then c is understood to be 0. Okay, so b is 8, m is 4. Don't forget to do the opposite of that. And c is negative 3. So the vertex is negative 2, negative 3, negative 2, negative 3. From there, I look at the number in front of x, the slope, and I do a positive 4 slope of up 4, right 1, and I also do a negative 4 slope because I've got to make a V shape. 1, 2, 3, 4, 1, 1, 2, 3, 4, 1, and that is it. That's your V shape. And I'm not using a straight edge, but you should. Something like that. So that's your answer for number 10. Okay. Writing these equations for a line passing through a point and perpendicular to another line. First thing I need to do is figure out the slope of this line that's given in the problem. Well, you've got a couple of ways of doing it. Let's just do what's familiar. Let's solve this for y, and whatever then is in front of x will be the slope. So subtract 3x, divide by 6. Negative 3 divided by 6 is negative 1/2. So we've determined that the slope of this line is negative 1/2. Okay, well, perpendicular lines have slopes that are opposite reciprocals of each other. All right, so the opposite reciprocal of negative 1/2 is positive 2. So I'm about to write an equation. My answer will be the equation for the line that goes through this point and has this slope. And I'm going to use this method. Just think about slope-intercept form. You're given x, and you're given y, and you're given, or you found out, what m is. So y is negative 2, m is positive 2, x is 4. We're going to use all three of those numbers to help us find out what b is. And when we subtract 8 from both sides, we find out that b is negative 10. So taking our slope of 2, our y-intercept of negative 10, we have our final answer, y equals that. Y equals 2mx, and then b minus 10. That's your answer for number 11. Okay, number 12, we have two functions, and we're supposed to evaluate each function using certain numbers, and then when we're done with that, we subtract those results. So let's find out what f of negative 5 is. That means in this f function, I'm going to replace x with negative 5, and then see what comes out. In other words, if you let negative 5 be an input in this f function, what's the output? So negative 2 times negative 5 is 10, and 10 plus 4 is 14. Okay? Now let's evaluate the g function using 3. So if 3 is an input in the g function, what is the output? All right? So we always do inside the absolute value first, negative 9 minus 7. That's the absolute value of 16, which is 16. Okay, final step. We found out what f of negative 5 is. We found out what g of 3 is. This says to subtract those numbers. So my final answer is going to be 14 minus 16, which is negative 2. That's the answer for number 12. Okay, if y varies directly with x, that means we have direct variation, and y is 4 when x is 3. Just make a fraction, y over x. Do equals, and then make another fraction of y over x. You just don't know what this y is, and that's what we're supposed to find. So this is called a proportion. So with proportions, the way we solve them is we cross multiply. Let one product, 3y, equal the other product, 24. Y is 8. So my answer for number 13, y is 8. So set up two fractions that equal each other. Just be careful if you do y over x on the left side of the equation, make sure you do y over x on the right, and you'll be in good shape. Cross multiply and solve. Here's our last problem. Solve and graph, and this is going to be a number line graph. So my first step is to isolate or get this absolute value part of the problem all by itself on the left side of the equation. So that's going to involve two steps. My first step is going to be to add 9 to both sides. Okay, so we've added 9 to both sides, and this is the result. And now my second step is to undo multiplying by negative 4 with division by negative 4. And don't forget, we've had this happen a few times on this test. Dividing by a negative number means we have to switch the inequality. Okay, now with absolute value inequalities in one variable like this, when we get to this point, we have to recognize whether or not this is an AND compound inequality or an OR compound. And what I've told the class is just think of the word greater, but instead of greater spelled correctly, use OR. Anytime you have absolute value greater than, that means we have an an OR compound inequality. So I'm going to represent this as two different inequalities joined together by the word OR. There's one inequality, and notice what happens to get the other one. You switch the inequality sign, and then you change the number to positive. And now it's just a matter of solving for x. So add 3 to both sides. Add 3 to both sides. And that's our solution. All the numbers greater than or equal to -3 will work, or all the numbers less than or equal to 9 will work. And we're supposed to graph this, so here's what the graph looks like. Here's 0, we'll just say -3 is there, and we'll put 9 over here. Here is all the numbers, picture of all the numbers greater than or equal to -3. Here's a picture of all the numbers less than or equal to +9. Well, if you take both of those together and combine them, you're talking about every single number there is. And so to finish this off, we would say that our solution is any number, as long as it's real, will be a solution. All right, so those are the problems on the Chapter 3 Version A test, and I hope this helps.